So basically I work I'm interested in e-democracy. I've been working about e-democracy for quite some time. I've been developing e-democracy software that is software that let a lot of people decide things in a distributed way. I've also worked for the Senate. We wrote Italian Senate. There was a publication going on. I participated into that, and then eventually they wanted to make the Ministry of Innovation. They wanted to make a request to the citizen about how to actually change the constitution. So I was in charge to actually write the algorithm so that it was fair. And basically my work has always been to find out algorithms that are mathematically fair. Mathematically fair means that your vote should count as much as the vote of someone else, even if you heard about this issue before or after. I'll give you an example. Suppose that you have one of those platforms around, there are many, where you can just suggest an idea and you can vote on the ideas of others. Is this mathematically fair? That's trivially not mathematically fair, because someone presented their ideas before. They have much more time to receive votes than someone that comes out later. So you have to adapt a little bit. For example, an idea can be present on the website only for a finite amount, maybe for 1 month or for 6 months or something like that, so that you level the field for everybody, and so on. And there are a lot of tricks, there are a lot of problems, but even after you find and you solve many of those problems, and you come out with wonderful ideas and wonderful solution, you suggest to the government or to the local organizations how they should change. And the normal answer we got, and I actually got this answer from some politicians, was then if people are going to decide themselves, what are we here for? And this was is an interesting answer, and basically it's connected with a wider answer, that is, when you implement a form of democracy, then some people will be elected, will gain through this form of democracy, and there are many forms of democracy, and you can optimize it, you can make it better. But the people who are gaining from that forms of democracy often will actually not like how you're going to make it better. So it's in a sense easier to start again from the beginning and start from zero with a new system, with a new state, you would say, with a new nation or something like that. Now with the world is being completely controlled by nation states, you cannot just find some place and say, okay, I'm going to make a new nation over here. But on the internet, on the blockchain, you can start a blockchain with a form of democracy, and if this doesn't work, you can start another blockchain with a different form of democracy, and so on, making it better. But once you have one, it's really difficult to change it. Okay, that's a general problem. So the blockchain as a technology, so the blockchain single, as a technology, gave the possibility to multiple people to agree on the state of a database, basically. So that's what actually the blockchain does. The next step after the blockchain have been the DAO. It was mentioned before, DAO stands for Distributed Autonomous Organization. So now that you have a database, you can actually say, okay, we want a group of people over here, and they're going to be an organization. But we don't want this organization to be all in one room. We want them to be spread around the world. And in the moment in which you have a DAO, the important thing is this DAO can have some money. This DAO need to be able to handle this money, to decide where this money goes, for example. And there might be other decisions that needs to be taken. For example, how many other people are going to to be accepted inside the DAO, or how difficult is it, and so on. So this is the next step. This is the governance of the DAO. And the governance of the DAO needs to be distributed. If it's not distributed, you've lost your DAO, basically, because now it's not distributed organization anymore. You have a distributed organization with a central government. It doesn't work. And so there have been a number of forms of governance on the blockchain. Here are only 3. There are more than those. The first one is Bitcoin. And Bitcoin was the one suggested by Satoshi Nakamoto, whoever this person is, and basically is agree or fork off. And whereas anybody who disagrees with something, they can just make their own version and continue by themselves. I think it sounds nice. The first, I mean, there were several forks off in history. The first fork off that really was important was the one from Ethereum. How many of you remember the fork between Ethereum and Ethereum Classic? Okay, pretty much. At least half of the audience, and maybe some of the others were too shy to raise their hand. Basically, at some point there was. At some point, it was amazing because they made the first DAO, and so Ethereum was this wonderful platform. They started this project, raised a lot of capital. I think about 80 million, which now would be, it's an okay amount. But at the moment, it was a great amount, and it started, and it raised the value of Ethereum. So it started to have even more money. And then they decided to make a DAO, which was this organization based on smart contracts. Everybody could put money into that, and then people would vote on where the money would go. This money would be invested. It would come, in theory, with valued more and go back to the people that invested the money at the beginning. This was a wonderful idea. Too bad the smart contract had a bug inside, and someone started to funnel off money out of that. As a result of this, it was really interesting because Vitalik started, when he wrote about Ethereum at the beginning, he said, the code is low. Everything that's written in the smart contract, that should never be changed. Nobody has the right to change it. And even when at some point Ethereum was used to send money, I think, to Al-Qaeda or to ISIS or to whatever, he said, we cannot do nothing. We cannot change this because the code is low. Then when actually his name was up over there, and so many millions were put into this DAO, and he might actually be considered responsible for that. Well, yes, the code is low, but there are situations where we can actually change a little bit, and they decided to try a soft fork that didn't work. Then they did a hard fork, and then there was this first fork between Ethereum and Ethereum Classic. And now recently we had other forks because that fork seemed like something that was not that nice. So after that, people started to dread forks. They did not like forks. So in Bitcoin, they needed to discuss, to decide how to move on the system, and they could not agree for a lot of reasons that I'm not going to enter right now, about miners and who was gaining money from the current system and so on, and everybody, you have to do like we do, like we say, we're going to fork off, and nobody was actually forking off. And then eventually people started forking off, and there was a first fork, and the result of the first fork was that Bitcoin raised in value a lot. And the new coin that came out of this fork was actually a valuable coin that was worth hundreds of euro. I mean, when the Bitcoin was worth 1,000, that was still worth like 1/10 of that, or even more than that. So then there was a second fork that was coming out, which was Bitcoin Gold right now. Apparently that was not as serious as Bitcoin Cash. I heard, but basically, as soon as the other fork was coming, everybody started buying Bitcoin, and the price of Bitcoin raised a lot because everybody wanted to have 2 times the amount of coins. You know, they're Bitcoin and they're Bitcoin Gold. And now another one is coming out, which is Bitcoin Segwit or Bitcoin 2 or Bitcoin 2x and so on. So this is the Bitcoin, the fork model. And the fork model is specifically a governance system about the code, about which code has to be run. But then you have other forms of voting out there. Another one is the Dash masternode voting system, which has been copied in many other places. I think Dash was the first one to come up. Yeah. So the Dash masternode system works like this. You want to let people who are involved in the currency, who have a lot of meat in the game, to actually be able to vote, whereas someone who is not really involved do not have this right. So you need to distinguish between those 2 types of people. How does it work? People who have at least a certain amount of money, so there is a threshold, you need to have that amount of money in that coin, and you will have to put all this money in a single address and freeze it temporarily for a certain amount of time. And in the meantime, you gain things. In particular, you gain the possibility to vote, and you gain money in forms of governance. So if you know how Bitcoin works, the miners are actually the one that sign those the transactions, and they get the money that is produced by the blockchain. So they started getting 50 Bitcoin every 10 minutes, then it was 25, now it's 12.5, and so on. In Dash, this money that gets produced doesn't all go to the miners. 45% goes to the miners, 45% goes to the masternodes, and 10% is up there for projects. So if you have a project, if you would like that project to be funded, you can go to the website Dash Central, you can write about this project, and you can request some money for your project. Requesting money costs money itself, so that you're not going to lose the time of those masternodes. I think it costs too much money. I think the price to make a request is too high. But a lot of people, in particular the masternodes over there, think that it's fine like this, or actually they would even rise it more. Because it costs something like 5 Dash, and right now 1 Dash is 230 euro, I think. So that's about, what is it, 1,000 and something euro. But you know, you might have a proposal that where you request 20,000 euro in Dash, and if the proposal is nice, if the Dash community will actually gain from this, then they will actually fund it. Okay, so as a result of this, the Dash system produces, they have something like a certain number of millions every year, something like 28 millions a year, that they use to fund projects. What kind of projects do they fund? Well, for example, their own code writing. As a result, the wallet of Dash works really, really well, because they have a huge team of people working and making sure that it works for all the various systems, there are no bugs, and so on. They have a very good advertisement, and so on. Whereas in Bitcoin, you have to work on, thanks to the, it gets progressed thanks to the work of volunteers. And volunteers usually are funded by competitive organizations which have their own agenda, which is one of the reasons why you end up having all those big fights. Okay, so inside Dash you actually have some voting and some people who are allowed to vote. We're going to go back to this. But those voting in Dash has only control of this money. That's as much as it goes inside Dash. Okay, in Dash it costs a lot having a masternode. It's like 200,000 euro to have one masternode. But there are other coins, and the value of masternodes, depending on the the various coins, goes from 500 euro in some coins to, I heard, 2 millions in one coin or something like that. Then you have Tezos, and Tezos is another really interesting idea, and is an idea where there is the code, and now here they particularly faced the idea of governance of how do you change the code that runs the blockchain. So we are back at the Bitcoin. Okay, so you have the same code that all the miners are running, and then someone says, oh, I think we should make this change, and they submit it as a request to be added. And other people present other possible changes. And then people in Tezos, again, there they call them stakeholders, I think, and I don't remember exactly what are the qualities you need to be able to vote, but probably something similar to the masternodes. Some people in Tezos can vote and decide which code get added and which code does not get added. Now, the code that gets added could potentially also change the voting system itself. So now you have a system where the code can change itself. The code votes for its own change. As a result, if you start 2 or 3 different instances of Tezos separated, separated from birth, then people vote for different changes in the code. You might end up with completely different coins later on. So, but what kind of decisions? Okay. Okay. You can read. I hope.
Yeah.
So, what kind of decision? In a lot of those slides, I will put here some open problems. I choose this format because this is a work in progress. And it's not just work in progress by me, this is a work in progress by the community. Everybody is trying to solve this. A lot of people are working into this. There are many communities, there are labs, there are people who have solutions and so on. And there are some of those problems that have been recognized, some that have been partially solved, and so on. So this open problem will somehow represent how far we have gone. So if we need to have a governance, a system of governance inside the blockchain, as I said, I've worked in a decision-making system from probably from 2005, and then specifically on this from 2009 in e-democracy. One of the things I realized is that it is a failure strategy to try to get a single type of system that works for every kind of decision making. There are different kinds of decision making that have different mathematical properties, and if you want to optimize for their mathematical properties so that the result is actually what really represents the will of the people, you need to consider the various mathematical properties of the various questions. So the simplest one is, which of those 2 proposals? Would you rather have A or B? Or would you like A, yes or no? Same question. These kind of questions are the most simple. You can solve them just by a raise of hand or something like that. There are not a lot of mathematical problems with this. The problems come at the next one. What if you have n different proposals? It's a closed question. There are only n possibilities. Like in Tezos, you have n possible code changes. Which one of those code changes, if any, do you want to implement inside the code? This is a different kind of question because here you have to apply different forms of voting. We are going to look at this one. Now, the next one is, suppose instead that you have to decide a value of a parameter. And to make it simple right now, let's consider a one-dimensional parameter. You know, the speed of the highest speed of the car in the highway, or the amount of bitcoins that are going to be produced by this year. The amount of your coin. You know, you're about to launch a coin. You need to decide how many are those going to be printed in this year. And so now it is an open question, but open within a parameter. And it has some specific properties, some mathematical properties that make it actually easy to solve. In fact, it's actually easier than this one above. And then you have, what if you need to find the right answer among an infinite amount? So you cannot list them all, you know. That's another problem. And then what if you have to elect a team? For example, there might be some problem where, you know, it's just not good to vote on every single decisions, but you want to elect a team who does this particular job and then gets released. So those are different kind of decisions, and my claim is that a system, a blockchain system, a distributed blockchain system that have governance inside needs to have implemented ways to tackle each of those as a separate strategy. So in every moment, we have to solve this one, we use this strategy. We have to solve this other one, we have to use this strategy. So, but who gets to vote? That's another big problem. And there is a balance between democracy and plutocracy. And by the way, plutocracy has nothing to do with Pluto the dog. Plutocracy means the government of the rich. And that dog, in Italian and also in English, is called Pluto. I don't know in the Netherlands how it's. Non sapevi che Pluto?
No, I don't know what is the
Same. Yeah.
Sorry?
Yeah, they say it's the same.
It's the same. Okay. And so basically, if you have master node owners who are voting, and to be able to vote, you need to have so many 100,000 euro invested into that one. Now at that point, yes, it's one thing to have skin in the game, but now you're actually starting to have to move to a decision making where only people who have a certain financial ability are able to actually take decisions. Are you sure that they really represent at best the community that wants to be there? You know, this depends on how big those master nodes are. And as you move this number, which is a number by the way, so we go back to the previous question, one of the previous question, you move between democracy and plutocracy. And so, for example, while on Bitcoins, the miners are the one to vote. And again, to be a miner right now in Bitcoin, first of all, you should not be in Italy because the electricity costs too much. And seriously, there are a lot of places where you cannot physically be a miner. And then you have to actually be, putting a lot of money into that, buy a lot of equipment, and so you do not represent anymore the community so much that in the last decisions, the community was very. You could see very easily, first of all, a division between developers, miners, and everybody else, and then the developers started to split and so on. But that was the first division. So what kind of decisions needs to be, before we spoke about the kind from a technical point of view, but then what decisions usually those DAOs, those communities around the blockchain need to decide? So first of all is the production of money. So all those coins have a certain amount of money that gets produced. How much of this money should be there, should be produced? Is it a fixed amount? Is it something that that we decide every time? And if we decide every time, how are we going to vote for that? Changes in the code, very important. Look at Bitcoin right now. Which project to finance? Look at Dash. If it's possible to finance, if you have extra money. There might be other micro decisions, other things that you need to decide. But then there is another thing over here. You remember what happened in Ethereum. You remember when that hacker stole all this money. Actually, technically speaking, he did not steal it because the contract said, well, we are going to do this, this, and this, but by the way, it was written at the end of the contract, by the way, this is not actually the real enforced contract. The real enforced contract is what's written on the blockchain, and that is what is should be considered as the law. This was actually what people have signed. I know because I sent, like a tiny amount just to be part of the game. And so deciding which kind of behavior is illegal, that's if there is any behavior, is another kind of decision. And this leads to an open problem, that is, how do you enforce those decisions? For example, if you look at Dash, sometimes in Dash people will discuss about changes in the code. But while the decisions and the votes about money is immediately implemented, because inside the code it takes the votes and on the base of that it changes who to allocate the funds. If they say, well, the developers should do this or should do that, this is just a suggestion. There is no direct way of changing the code. Very different, for example, from Tezos, where automatically the code should be changed. By the way, Tezos right now, I think they're going through lawyers because they're having a lot of legal problems between part of their organization and their financial organization that are overlooking them. So, which is a little bit interesting from a group that was going to show to all of us how governance should be made. Now let's go to the technical side, and in particular we want to speak about which of those end proposals, because this one we know how to solve it. So let's go to the next one. How many over here knows what a Condorcet Winner is? Well, if you haven't read it. So if you have n proposals, and you have you have n proposal, and now you start to make elections 2 by 2. So you take this proposal and this other one, and you see how many would prefer this one to that other one. Then the A respect to B, A respect to C, A respect to D. If you have one proposal that wins against all the others, this is called a Condorcet winner. This is something from the Marquis de Condorcet. We are speaking about 1789 French Revolution, that kind of, some of the theorems that he managed to get through before having his, he did not have his head cut off because he was killed before in prison, but he was about to have his head cut off. But he managed to get the revolutionaries to use Condorcet systems for a certain amount of time, by the way. So here is an example. Imagine you have 5 candidates, can be 5 projects, 5 proposals, 5 code changes, and you have 100 people voting, and this is how people in academia consider that voting should be done. It can be done in other ways, but often this is the way they do it. They want people to order all the proposals. So you don't only vote for one, you order all the proposals. If you are only interested in voting for one, you are basically ignoring this part and just picking up the first one. So if you only vote for one, the winner is obviously Alfio because he got 33 votes, and so on. So suppose that those are all the possible, all the preferences of those 100 people, and now you can make a graph, and you can say, suppose A and B. How many people prefer A to B, and how many people prefer B to A. And here you have that 33 prefers A to B, but then you have 16 prefer B to A, 3 prefers B to A, 8 prefers B to A, 18 prefers B to A, and 22 prefers B to A. So 33 prefers B to A, and 67 prefers, 33 prefers A to B, and 67 prefers B to A. So now we put an arrow between B and A to say that B has, in this comparison, people prefer B and A, B to A. So now there are all the other arrows. I'm not going to go through, but you can see here that there is one element from which all the arrows goes out, and that is C, which means that C is the Condorcet winner in this example. So it would make sense to elect C. Now, wonderful, so we solved this problem. We can just take the Condorcet winner. Well, not always, because if we just invert what those 33 people wanted, you know, Dino, they preferred now Dino to Caio. Now D becomes preferred to C. So basically you have that D is preferred to C, C is preferred to B, and B is preferred to D. Whoops! So you have what it is called a cycle, a Condorcet cycle. And what do you do when you have a Condorcet cycle? Well, people find different solutions. There are different forms of voting. One form of voting checks the relative amount with which people prefer A to B, B to C, and so on, and they start to take away the arrows that are weaker. That's a solution. I like another solution that actually was not done by me, but it was inspired by some work that I did, which is if you don't have a Condorcet winner, you don't take a decision, and you try to find new candidates. So basically saying we don't have something which is strong enough for everybody else to agree, so for now we should not take a decision. But also, you should also know something else, that as the group of people that participate grows, the probability of having a Condorcet cycle decreases. That's something I read. I never saw the proof of that, so I trust it, but check it out if you're going to use it as a theorem. But
what about removing the least popular?
Yeah, you do that. If you remove the least popular, you still arrive to the cycle. You remove A, then you remove E, and then you are in the cycle, and now you do not. What does least popular when people prefer C to D, C to B, B to D, and D to C? Now what does?
Also, if you vote again without the least.
Oh, you still get the same.
Yeah.
You still get the same because you can just delete it, but you still get the same.
But what about having votes? Let's say everybody gets 100 votes, and then they can distribute points according to the type of candidate that they would prefer.
So all the things that you are suggesting are the various ways with which people have been trying to tackle this in the last 300 years.
Yeah.
Now, a Condorcet voting system is a voting system that if there is a Condorcet winner, it will elect the Condorcet winner.
Yes.
If there is no Condorcet winner, it elects something.
Yes.
Okay, and it doesn't even have to be in the cycle. The one that you have just suggested, for example, doesn't always elect the Condorcet winner. Okay, but you might say, yes, but I do a dual strategy. If there is a Condorcet winner, I use this one. And if not, I have to do this other one. Yes, but are you asking people to vote twice?
But do you feel that what I just suggested of having this, let's say, everybody gets like 100 votes, and then they can distribute. So they can give Alfio just 1 vote, and they can give Baggio, they can give 35 votes, right? And decide to give no votes to Dino. So that there's a complete freedom of expressing a certain force with which they prefer a candidate.
There is something in voting theory which is called strategic voting.
Yes.
Strategic voting means that although you like some particular solution, you actually don't vote in a way that represents your solution, because you think that if you vote in the way in which you represent your solution, your probability to get something that you like will be lower than something else. As a result, with your kind of system, people for strategic voting would actually just put all their votes in the element that they consider have realistically possibility to win. Among the ones that have realistically possibility to win, not everybody can win. Some people have.
Right.
So among them, the one that they think has a higher chance. As a result of these, people are not voting honestly.
Okay.
They're not really representing. One of the idea is, can we actually get people to vote honestly, and as a result, find out a solution? But there's also some really interesting work that is being done. The last time I heard about it was from University of Padua on recursive voting, where people vote one time and then they vote again and then they vote again, even with very simple plurality voting. Plurality means they just vote with one number, just the first one.
So we do with the Pope, isn't it?
Sorry?
So that's how the Pope is chosen.
Yeah, in a sense, yes, exactly. The Pope is chosen like this. I haven't thought about it, but yes. So, and interestingly, they made some tests and they found that plurality voting with recursive voting has a very high probability, but not security, of finding a Condorcet winner.
Can you explain this recursive voting? Because I have a little
Sure.
bit of a comprehension problem.
So, for example, you want to elect the mayor of something, and so everybody gets to vote, and then anytime they want, they can change their vote, until they decide they don't want to change their vote anymore. There is an election, and you can see what the result is, and after you see what the result is, you can change your vote. But everybody is changing their vote, so this changes the result.
Yes.
And you keep on until you find a situation where you're not going to change it anymore. Okay? So we use that on Vilfredo, for example. Vilfredo is my pet project, is the one that I like most. And
which project is
everyone
that?
agrees in not changing it anymore.
yeah, the idea is everyone agrees, but there is a voting fatigue at some point. I mean,
What was the name of your project? You just mentioned the name of your project that's dealing with this particular.
the one, no, the university is University of Padua.
Padua, yeah.
I apply this on Vilfredo, which is a particular system. We're going to speak slightly about it. I hope.
Okay, sorry. Okay.
We have
We don't have a lot of time. Yes,
5
the time is time.
10 minutes.
15. Okay. So the problem with Condorcet is that there isn't always a Condorcet winner. We spoke about it, but when there is, those are considered as really good result. But then there is a case where there is always a Condorcet winner. So there is a use case which we are interested in when there is always a Condorcet winner, and that is the theorem of the median voter. I should have put a picture over here. Suppose, you can go theorem of the median voter on Wikipedia, you find everything. Not explain this well, actually. So suppose that you want to find a value in a one-dimensional set. The speed of cars on the highway. That's the example that I make every time. So that's a number. Now suppose that each of you has the speed, the maximum speed, the speed limit that should be on the highway. Now suppose that each of you has their own favorite speed limit. I think cars should go at 120 kilometers an hour. Another one, no, 160. Another one. So everybody of you has a favorite value. And imagine that as you move away from that favorite, how much you like the result goes down. Okay? So those are some basic requirements, but are not that difficult to reach. This is called having a single peak situation, because everybody has one element that they like very much. Now this means that there is always a value that is a Condorcet winner. That is, there is a value that everybody will prefer it respect to all the others. So if you vote for every speed and every couple of speed, even though they are infinite, you vote for all the couples, you find out that there's going to be one that is preferred respect to all the others. And so there is a Condorcet winner. But not only this, it is actually not only it exists, but it is possible and easy to find it. And how do you find it? You find it by asking everybody what their favorite speed is, and then you take the median of all those votes. So this is an example. Each of those says how much do they like the various speeds. Antonio like 30 an hour. This is inside the city, not outside, of course. This one, Barbara likes 50. Carlo likes 60. This one likes 40, and so on. So basically, you have this kind of graph, and the median is in the center. You're taking the median. Sorry, this should not be here. This was... So basically, if you compare this value with any other value, actually the majority of people will prefer that value respect to others. But it's not always the same majority. I mean, if you're comparing this one to this one, the majority will prefer this one. If you compare this one to this one, the majority will prefer this one. But the people that are voting for this one on one side or on the other are not going to be the same people. Okay, that's clear. So at that point you take the median and you decide that that is the result that the community wants. Fine, so we solved it. I tried this one with some of my friends. In Italy it's illegal to pay with cash things too much all at once. You need to pay with credit card or with other forms. So I said where this threshold should actually be, and I asked some of my friends to vote, and I got those kind of votes, and I put it, and the median was about 5,000 euro. This was the median. So if you order them, you find out that the median is just over here. Interestingly, some person voted huge amount. Did this change the median? Not at all, just by one element. So this is why you should use the median and you should not use the average. If you use the average, you are basically at you can be manipulated by the extremists that actually vote incredibly high or incredibly low numbers. Also, if you use the average, you cannot do recursive voting because someone sees how everybody else has voted, makes a few calculations, and just votes for 37,224,000 because just with that number I get exactly the average that I want, and something else I don't. So, and notice how easily the median was reached. Eventually, after just 11 people, the median was reached, and from then on, it was fixed. So it's a very stable system. You actually don't need a lot of people to vote. It's pretty easy to find out what a community wants, which is important in a situation where people have a voting fatigue. You don't actually need all the master nodes to vote for something. You can just pick randomly 20, 30, 40 master nodes and ask them to vote for something, and then for another decision you pick another 40 people. So it's resistant to strategic voting, we said this. This is how it's resistant, I've already said this. This is how average is not resistant from strategic voting. You see this guy who made a huge vote, it raised everything. But it has a problem. You are basically ignoring completely the point of view of people who are at the extreme. Okay, you are balancing on the fact that people on one side of the extreme are balanced with the people on the other side of the extreme. Now, in democracy, we don't like this. This is an open problem. I don't have a solution to this. I actually think it's a great form of voting, but it has drawbacks, and this is one of them. Now, what if you have to ask yourself how much money do you want to print? And those are, Keynes and Hayek are the two big names. I have very little time, so Keynes and Hayek are the two big names of economy. Keynes is speaking about having a finite, a certain amount of inflation that would help in the economy, and Hayek instead having more money connected to the gold. And this moving on, right now you have the fiat currencies with Draghi, that is whose job is independent. What he swore into office when he got into office is, independently of the politicians, I'm going to print money in a way that the inflation is always set at 2%, I think, or between 1 and 2%. I don't know, either between 1 and 2 or 2%. 2%. Okay. Whereas the other side, in the Bitcoin community, we have this deflation system where there is a fixed amount of money, which is like gold, and as a result, the value of this money grows as time goes by. 1 Bitcoin now, it's worth much more than 1 Bitcoin 1 month ago. And but if you write a new currency, are you sure that you want to have it as a store of value so much? Maybe yes, maybe no. I mean, if those are tokens that people use, maybe you want people to use them and not to just hoard them, and so maybe you wanted to print money, but how much money? Well, you need to employ someone to decide that, someone who is an economist, who worked all his life into being an economist and so on. Well, maybe there is another solution. And the other solution is using the wisdom of the crowd. And this picture is coming from this book, but actually the paper was from 1897, I think, or 19 between the 1900 and the 19th century and the 20th century. And basically the idea is, here is an ox, and they asked people to evaluate how much did it weigh, this dead ox. And those were all farmers, and whoever catched the value most near the value of the ox, he would gain something. So they all wrote their own value, wrote it down, and the result, the average of 800 guesses was 1,197. The actual weight was 1,198. I actually tried this in a bar. There was I took something like this, filled it up with sugar lumps, and then went around from person to person asking them to write down how many sugar lumps there was inside. And there were something like 33, and the median was 30. Why did I use the median while he used the average over here? Generally, if you're afraid that people might actually not vote what really is the value seriously, then you want to use the median. If instead there is an incentive for people to actually write the right vote, then you can use the average. Okay? And so when you do something like this, the average or the median is as close or nearly as close as the best expert. Now, why can't you just employ the best expert then if the best expert is better than the average? And sometimes the best expert is better than the average, because you don't know who the best expert is. This time the best expert was this farmer from from Dublin, this other time, the best expert is this other farmer from Lazio, and you have no idea who is going to be this time, whereas the average is always the average. So in a situation like this, you say you let all the master nodes vote, and then you take the median. And this is what would take the point, would be, who would substitute Draghi in this situation. So you substitute the expert from in this way. So we have different kind of decision. This we solve it with voting. This we solve it with Condorcet voting. If there's no Condorcet, well, maybe we wait. This we solve it with the median. What if you need to find the right answer? Then you can go online, go on my YouTube channel and find out how Vilfredo works. And I just have a number of new videos that really explain it in details. So that's great. The problem with Vilfredo is that it doesn't scale. So it only works up to 20 people, and it's not for computational problem, it's for mathematical problem, so you really cannot get out of that. But when you have to have a really complex task, sometimes you apply a team to that. You can actually use a voting system among the master nodes to decide who should be in that team, and then that team will use Vilfredo to decide in a transparent way. As a result, and now the cycle is complete. You have all the forms of voting, and then you have a problem, and now you say, okay, how do we solve this? Well, which system should we use? Question type of 2, because we have those kind of systems. How big should be a team? Oh, question number 3. Who should be in the team? Question number 5. So basically, using those building blocks, you can actually use it for all sort of decisions. And
isn't there an assumption that everybody has equal access to information? Because in the blockchain, there's people who are in the know and people who are not in the know.
No, there isn't, because that thing about the master node, about the OX worked even though people did not have, because the people who don't have access to information, some will be biased in one direction, some will be biased on the other, if we are speaking about the parameters. In other situations, yeah, the handling of the expert is always the most difficult part of a democracy. And I started writing a book on e-democracy, and for 2 times I stopped, and 2 times at the chapter of handling the experts. So blockchain governance is coming. There's still many open problems. Maybe you've seen all those red ones. And once installed, it's hard to change, so we should get it right at the first time, or get a new blockchain. And if you want to learn more, there is my homepage. I have a YouTube channel, and I have Skype. You can ask, I answer. And I'm available for hire on this kind of things. Right now, I'm working with DNN, which is Distributed News Network. They are trying to become a media that stores on the blockchain the fingerprints of articles, and they want a system to sort out fake news from non-fake news through people voting. And I'm actually working on that, adapting a little bit some of the system I've worked before. Okay, thank you very much. Now there is a question.
Some questions.
By the way, there was someone asking a question over there all the time, so to get to you.
Just about the question with the power of the crowd. I think I've heard of that concept quite a while ago, and I was thinking it works when you have people who understand something about a subject, but if you ask everybody in this room in centimeters how wide is the universe, I think, then, so yeah, it was just a small point that I thought that it works in some cases, but I think the power of the crowd is only as much as the average person knows. The less that the average person knows, that variance is just going to grow a lot wider.
That's correct. I mean, those people in that market, they were farmers.
Yeah.
Okay, they might not be specified, but they were about on the area.
Yeah.
Yeah, and that's why those questions that I looked, that I spoke about, were, the speed in the highway or even the money printing. This is something that, you could handle about it, you could get information about it and so on. If you're thinking about how to make a chirurgical operation, I still would go for a surgeon.
So would you take the median or the average in that case, if it was a complicated?
No, a single surgeon, I just take him.
Yeah.
I pay him well, and I say that I pay him after the surgery.
I was always led to believe that we have politicians, we choose them because there are decisions which are very difficult to make on a one-dimension scale. How do you fit that in with this? I mean, I appreciate it's wonderful, but there are things I believe you need to value and weight pros and contras.
Indeed. So there are two things that needs to be said about this. The aim here is not so much to substitute politicians because this system is better, which might also be in some cases, but we want to substitute a centralized system with a decentralized system. And if you're using a decentralized system, you are forced to have something which is decentralized. The moment in which you have some people that represent other people, that represent so many voters and so on, then basically it's starting to become centralized again. Then basically if you want to take down Bitcoin, I mean the reason why we have Bitcoin is because it's decentralized and the government cannot take it down. Because if not, the government would take it down, like they took down so many projects before. So that's one of the elements. The second, I recently was at the Camera, the other house in the chamber in Italy, presenting in an informal meeting, nothing fancy, a form of voting that I have developed. And I was amazed actually by the intelligence of the people I spoke with. We are used to politicians as stupid people, because that's how the media represent them. People we can mock and so on. And I'm sure that among the 1,000 politicians that we have in Italy, among the 300 of the Senate and 600 of the chamber, there are surely some people that are not bright, to say the least. But to think that they're all like this is not true. Nevertheless, when you look at all the decisions that they make, I don't think that they are actually, studying so much and always. Sometimes they are, sometimes they are not. So maybe a system like this can achieve a similar level of quality.
But at the same time, whenever there is a decision, it's not. It's also the product not just of the politicians which are there, but also of some lobbying. Of course, if there is a decision concerning agriculture, the agricultural sector, which will have a word much more than all the other participants in the political system. So, could you imagine, for instance, implementing something like your voting system within some particular hubs or interest groups? I don't know. Of course, I think there would be some also negative sides of this, but doing this. But
well, that's a very interesting thing, because maybe you don't want that there are so much lobbying. Maybe you want the lobbying is transparent. The lobbying forms is in the form of information out there. If I am, if I represent some specific groups and I want to influence the one among you that are master node owners and I don't know who they are, now I cannot pay you for this, or someone might come to me and say, well, I'm a master node owner, can I have this amount of money? And maybe I don't know if I can, I might be able to actually check it out. I don't know, I would have to think about it. but there is the possibility that it might make it transparent to the whole lobbying system, which is something which is very much needed. And of course you can apply it for every group, something like this. Sorry, before the question, I kept on seeing a hand rise in this area for all my talk, during all my talk. Who was? Okay, maybe it's gone. Okay, so please.
I have a question about prototyping. I mean, I think it's a really pressing thing to think about decentralized voting. I think it is relevant for every one of us. But I think nobody likes to try a system on a nationwide scale. So I thought a lot about that. And is there any prototyping on a city scale already ongoing, or do you look into that at the moment?
We're not at that level. We are at the level of proof of concept right now. So not yet at prototyping. And some of those elements have been used at different, Condorcet voting. Yeah, have been used. My suggestion, I am trying to lobby, not gone so far very well, but to get referendums, local referendums in Italy using unidimensional system. So that would be great, for example. But the blockchain is also good because it permits you to try something small. And if you think that is good, then you participate in the ICO, you get a little bit of, you get some of those coins, you buy them from the whatever market, and then you have a stake in the game, and you try it. And if it works well, you sow well, then the thing is going to grow and you're going to gain. If it doesn't work well, you've tried something and it did not work.
Okay, maybe time for a last question, but very short.
So in Bitcoin, is the consensus mechanism of Bitcoin, is that voting, or in which kind of voting is it in your list?
No, in Bitcoin they use fork. They use forking system right now.
Okay, so there's no voting.
No, right now there is no voting. Absolutely, there is a form of voting in the sense that miners can choose and can signal what kind of code they are running. Although sometimes the kind of code that they are running, that they are signaling, is not honest what they are actually running. So that also doesn't work. Is sometimes a bit disingenuous. So.
Okay, thank you very much. Pedro.
Thank you. Thank all of you for the questions.
Okay, so conclusion, Valeria, come on the stage, please. We would like to express thank you to all that you came to our first edition.
Yes.
We hoped you like it. We would like to hear your feedback. So feel free to write us either in comments or either in a PM at meetup.com. Your comments for improvements, we welcome in constructive feedback, not like criticism.